What would you do if your loved one is in need of medical attention but you're not close by? Microsaver, Beat It Safer, a project for Intro to Engineering for Dr. Zambrano by Angelica Casanova, Lucero Torres, Darius, Lott, and Jose Ezquivel. For our project, we used the 10-stage design process. Stage 1 of the design process is to identify the problem. Our team worked together to develop a new way to improve the use of pacemakers, their functions, and the way they perform. With this, we try to reduce the risk of a heart attack or any other heart diseases not being detected on time. We also use technology in a new and improved way that can help save someone's life. This will help not just the patient but the rest of the family members to have a constant update on what the patient is going through and to prevent death from a heart attack. Once we identified the problem, we needed to establish certain working criteria, which take us to stage 2 of the design process. How much will it cost? This product should be very low cost in production, since we're trying to improve patients' medical condition. The cost will depend on different factors, such as the makers of similar products. The feasibility. Since products with similar functions are already available, we agree that it should be easy, but will also vary on the point of view of biomedical engineers and software engineers. What will be the size and weight? The size of this product will be 2 mm squares and very lightweight. Will it be easy to use? Since it will be built in on a pacemaker, it will be easy for both patients and doctors. Will it be safe to use? Yes, it will be safe to the patient to use, as it will be capable of saving his life. Will it be reliable and durable? Yes, this device should be reliable for patients to trust 100% and lifetime durable. Will people want to purchase it? Yes, patients and family members will be excited and ready to get this tool that is capable of saving one of their loved ones' life. Is it friendly to our environment? This device will not be harmful to the environment because of its size, and proper disposal techniques will be implemented. Stage 3 of the design process is to research and gather data. Is there a solution to the problem available? There are no available solutions. We have tools, we have the materials and technology to develop this advancement. However, the concept of a microchip inside a pacemaker is a new idea and will make life easier for the people in need of such device. We researched 2 types of microchips that could be used in conjunction with the pacemaker. The first one was the analog microchip. The advantages for the analog microchip is that the signal processing can be done in real time. It uses less bandwidth and is very low cost. The disadvantages for this was that it required lots of energy or battery power. This, of course, could not work for us because a pacemaker is implanted inside of the patient's body. Option number 2 was the digital microchip. The advantages for this is that it works better for computing and electronics, and it does not require lots of energy or battery power. The disadvantages for this is that it costs more than the analog microchip, it cannot send data in real time, and it consumes more bandwidth than an analog microchip. Stage 4 of the design process was to brainstorm and generate creative ideas. Our goal was to create a tool that will help improve detecting issues going on inside the heart of a person with a pacemaker. We wanted an innovative product that can be implemented to our everyday use of technology. With this microchip, we can provide a scan on the spot of how well the heart of the patient is doing. We also can provide enough information about the medical record of the patient. For example, a paramedic can scan the microchip of such patient and receive all the information from the pacemaker. It can also help us with communicating between the patient with the heart problem and the family members. through alerts sent by the pacemaker to a mobile device. The following working criteria was established to ensure that the end product is cost-effective, is convenient, is safe, and is reliable. These numbers were discussed by the team, and we came to the conclusion that the cost was going to be 5%, the weight 10%, the feasibility at 10%, the convenience to use 25%, the safety 35%, reliability 10%, and the environmental 5%. Stage 5 of the design process was to analyze potential solutions. Choosing the best solution that will give most accurate information was our number one priority, but we had to take into consideration which solutions are most cost effective. Narrowing the choices and choosing one that will be more effective for future use as technology improves was our final step in our analysis. We had two potential solutions. Number one was the analog microchip. With this, we found out that it gets affected by noise and lots of movement, making data transmissions less accurate. It's a cheaper option, but very limited data can be transmitted at any given time. We also found out that it was better suited for audio and video transmissions, and it's becoming less commonly used and will probably not be used for future technology. Another thing was that it cannot use electronic devices that send waves like cell phones. So if we wanted our microchip to send alerts to mobile devices, this potential solution will not work for us. Although the digital microchip is more expensive to produce, it's more immune and less affected by interrupted noise, making data very accurate. It is also flexible in implementation, and there's less power needed. Stage 6 of the design process was to develop and test models. Each possible solution was analyzed, and the team came out with a narrow list of feasible options. This is the original sketch of a pacemaker. Stage 7 of the design process was to make the decision. For this stage, the creation of a table was necessary to evaluate the advantages and disadvantages of each proposed solution. As you can see on the decision-making table, the analog microchip scores 78 points out of 100 points available, where the digital microchip scored 96 points, making it a much better solution for us. Stage 8 is to communicate and specify. The pacemaker will have the use of an ordinary pacemaker already in the market. However, the microchip will be in charge of keeping vital information and collecting data from the pacemaker implanted in the patient. It will obtain not only heart records as well as to be able to send alerts when irregular data is recorded to the patient and their family members through a text message and app. The pictures on this slide not only shows the prototype of the pacemaker, but it also gives you a glance of the mobile device app that will be integrated with this product, as well as standardized messages that will be sent in case of an emergency. On number 1, you see the prototype of the pacemaker with the microchip integrated. Number 2 is the mobile device app that will be part of this product. On this app, that can be downloaded on the patient's phone as well as any other mobile device that he authorizes. You can put all your emergency contact numbers. It also has all the data from the pacemaker, and it has the availability for you to ask questions to your doctor. We also included a calendar for you to log any upcoming appointments, as well as the location pinpoint in case of an emergency. Any family member or an emergency response system can find you quickly. And number 3 shows 2 of the standardized alert messages that can be used with this app. Number 1 is the emergency alert, where it shows that there's a heart failure warning. Heart rate has slowed down to 30 beats per minute. Call 911. With this, the family member can call 911, find out the location of their family member, and send an ambulance to that location. Number 2 is just a regular emergency alert where there's a heart failure warning, heart rate has slowed down to 45 beats per minute, and the pacemaker is now taking effect. Stage 9 of the design process is to implement and commercialize. Microsaver has gone through all the necessary steps, from research to design, cost, and the benefits to the public, and it is now ready for production and implementation. We're going to seek the management and key supervisory personnel. We're going to select personnel that will make the ultimate decision to send the product into production. Key factors that will take place include the long-term goals and how the product can benefit patients that are in need of a pacemaker or are currently using one. In addition, this team will make the economic decisions based on the data collected through the research and personal decisions that will make the product ready for the market. The technical representatives, such as the physicians, technicians, computer designers, the web and app developers, computer engineers, and machine operators, will have the primary responsibility for getting the product ready for the market. Business representatives may consist of the human resource personnel that will oversee the team of technical representatives needed to bring the product to life, the financial people that will handle the final budget and financial analysis throughout the process, the purchasing personnel. They will procure the needed materials and supplies from physicians to research and data to companies that sell the most efficient microchips to computer programs that will enable technicians and designers to make the best applications for the product to function accordingly. The marketing and advertising staff members, this team will promote the product throughout the use of commercial ads, magazines, articles, websites, brochures, and public presentations and medical expos throughout the United States and international. The salespeople will be involved in the actual selling of the product and distribution, and the attorneys and legal support staff, these legal representatives will handle all the legal issues concerning the patent of the microchip, applications for the mobile devices, insurance, and risk protection analysis. Stage 10 of the design process is to perform post-implementation review and assessments. The product was reviewed by the team manager, quality reports, and the expenditures. We're able to conclude that this project was done following all the basic steps of the engineering design process, and during the time working throughout this project, we'll learn the essential use of these 10 stages that drive us through the entire process of design. Possible improvements to the design, to find the way to implement all ideas in one, and to improve the use of the pacemaker to have more than just 2 functions. And this concludes our project for Intro to Engineering, Microsaver, Beat It Safer. We would like to thank you for your undivided attention. If you would like to watch this video again, it will be on YouTube, Beat It Safer Engineering Project. And if you would like to try our app, follow the link. It will be on the YouTube description page. It was a pleasure working with my team members, Lucero, Jose, and Darius, and I hope that you enjoy our presentation for today. Thank you.